So today what we're going to be working on is solving radical equations. So these are square roots that are equations. All right, so I would like you to try this, which are simple quadratic equations. Okay, so what I want you to do is get the x squared by itself. So this one you have to add 7, and then try to think of a way to get rid of a square. Okay, put me on pause and give it a try. Okay, so let's look at the first one. We have x squared equals 9. So we can get rid of a square by doing a square root. When you square a square root, they cancel each other out. So then I'm just left with x. Now be careful on the right side over here, because when you square root 9, the answer is plus minus 3. Okay? Remember, because negative 3 squared is 9 and positive 3 squared is 9. All right, number 2. You actually have to isolate first. You have to get the x squared by itself. You can't do this. Oh, I'm just going to square root the whole thing. You can't do that. You have to isolate the x squared first. So we're going to add 7 so that the 7's cancel. So we have x squared equals 18. Now we can square root both sides. And they cancel each other out. So now I'm left with x equals, don't forget the plus minus, the square root of 18. Now let's simplify that since we can. So what perfect square goes into 18? That is 9 and 2. The square root of 9 is 3, so it's 3 the square root of 2. Don't forget to bring down the plus minus. So x equals plus minus 3 the square root of 2. Okay, so now let's talk about radical equations. This is really not too difficult, okay? You just have to remember a couple of steps here, a couple of things to remember. First thing is to always isolate, like I did back here, right? I had to, in order to square root both sides, I had to isolate the x squared first. So I had to move the minus 7 to the other side. So same thing here, I have to isolate the radical first. Make sure there's nothing with the square root. Okay, now, when you have a square root, it's opposite of what this is. When you have a square root, you square both sides. So we're going to square both sides. This part here you have to watch. If you're squaring a binomial on the side that's not a square root, you have to make sure that you double distribute. That's a common mistake here, so we have to be careful. And then you're going to solve, and then you're going to check. You have to check these because you could get answers that actually don't work. All right, so let's take a look at the first one over here on the right. First thing I check for, is my square root isolated on the left side of the equal sign? Yes, there's nothing else with this square root. So then I go to my next step, I square both sides. Squaring a square root will get rid of it. Square both sides. So the square and square root cancel each other out, so then I'm left with x minus 2 equals, don't forget to square the 5, 25. Now we're going to solve. So add 2. X equals 27. Now you have to check. All right, write down the original here. Square root of x minus 2, does that equal 5? It's a question mark. Is this true? So plug in x is 27, so it's the square root of 27 minus 2. Does this equal 5? So you could plug this into the calculator if you want the square root. Your calculator will do that. But it is the square root of 25 because 27 minus 2 is 25. And the square root of 25 is 5. And that checks. All right, let's try number 2. Okay, so when I look at this right away, I see my radical is not by itself. Okay, now remember the 2 on the outside of the radical is a times. And I have a minus. So just think for a minute. Let's say I have this 15 equals 2x minus 5. Well, what would I do first? Would I get rid of the 2 first or the minus 5? I would do the plus 5 to both sides, right? So same thing. I'm going to add 5. So I get 20 equals 2 the square root of x plus 5. So now remember I said this is times in here. That's what I would do next here. If I had 20 equals 2x, I would divide by 2. That's what we do now, divide by 2. So I get 10 equals the square root of x plus 5 because the 2's here reduce. Now I'm ready to square both sides. Square the right side, square the left side. 10 squared is 100. These cancel each other out, so I'm left with x plus 5. Minus 5 from both sides. X equals 95. Now you have to check it. So write down the word check. Write down the original problem, which is 15 equals 2 times the square root of x plus 5 minus 5 on the outside. All right, we're plugging in 95. 15 equals 2 times the square root of 95 plus 5 minus 5. And yes, you could actually plug this in the calculator. All right, but you do get 15 equals 2 times the square root of 100 minus 5. And then we have here 15 equals 2 times the square root of 100 is 10 minus 5. Remember, this is times, so this is times here. 15 equals 20 minus 5, and 20 minus 5 is 15 equals 15, and that checks. All right, so now let's try number 3. All right, so number 3, I noticed right away that my radical, I have this plus 1 here. 1 plus this. So you have to get rid of the 1. All right, so we're going to minus 1 from both sides to start off. Now be careful, because this you can't actually subtract. It's just x minus 1. Equals the square root of x plus 5. Now we can square both sides. So when I square the square root, they cancel each other out, so I have x plus 5. Now this side over here, you have to be careful. See, I'm squaring a binomial. So remember, you have to do x minus 1 times x minus 1. We have to double distribute. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Let's clean up the left side here. Negative x minus x is negative 2x. All right, now you have to say, all right, well, this is not like an equation from before, right? It's quadratic. And how do I know it's quadratic? Because it has that square here. So we have to move everything over to the left side. So minus x minus 5. So I get x squared. Negative 2x minus 1x is negative 3x. 1 minus 5 is negative 4. And then this whole right side becomes 0. All right, so it is a quadratic equation. We could, I wouldn't complete the square for this because the middle is a 3, so I wouldn't do that. You could use a quadratic formula or you could factor. So I'm going to factor because it is factorable. So remember, I multiply the first times the last, negative 4x squared. What multiplies to 4 minuses to a 3, that would be 4 and 1. So it would be 4x and 1x. When we multiply 4 times 1, it has to give me negative 4. That means they have to be different signs. That's the only way to get a negative. But when I add them together, it has to give me negative 3. So it has to be negative 4 and positive 1. Bring down the end. Make sure it still equals 0 because it's an equation. Bring down the front. Now, 4 terms, remember we factor by grouping. Group the first 2. Group the last 2. In the blue group, the GCF is x times x minus 4. In the red group, I see there's a plus here, so I bring the plus down. GCF is just 1, so it's x minus 4. Write your factors. Remember, it's what's in front of the parentheses, so it's x plus 1. And notice the parentheses, they're the same. They're supposed to be, so that's one of them also. Okay, now we make our t-chart. Set each one equal to 0. And now we solve it. Minus 1, x equals negative 1. Add 4, x equals positive 4. Now you have to check. So we're going to have 2 checks because I have 2 solutions. All right, so write down the original problem. The original problem is x equals 1 plus the square root of, hold on, I got to go back and look, x plus 5. X plus 5. Write that on both sides because we have to check both sides. 1 plus the square root of x plus 5. All right, so I'm going to start with the one on the right only because I know that one actually works. So let's check the one on the right here. Plug in 4 for x. So 4 equals 1 plus the square root. X is 4 plus 5. 4 equals 1 plus, you could plug, and you could even plug this in on your calculator if you want. But this is the square root of 9. The square root of 9 is 3, so it's 1 plus 3, and 1 plus 3 is 4. So this is a good answer. All right, now we're going to try -1. Plug in -1 for x. -1 equals 1 plus the square root. -1 is x plus 5. -1 equals 1 plus the square root of 4. -1 plus 5 is 4. So it's -1 equals 1 plus the square root of 4 is 2. 1 plus 2 is 3. This does not work, so make sure you cross this out. This does have a special name when you have something like this that doesn't work. Well, let me just get rid of this here. And you do have to make sure that you cross this solution out. This doesn't work. You actually don't have to cross this out, but you do have to cross out that x equals -1 because x can't be equal to -1. So now what is this called? When you have something a solution that doesn't actually work, it's called an extraneous. It's like an extra. See the word extra? Extraneous solution. Or an extraneous root. Okay, it's an extra root. It's a root that doesn't work. It's an extra solution. It's a solution, though, that doesn't work. Okay, so my only solution then is x equals 4. Okay, so that's it, and we'll practice in class tomorrow. Everybody have a good night.